Título: Proximate Analysis of Foods. Texto: This system of analysis divides the food into 6 fractions: moisture, ash, crude protein, ether extract, crude fiber, and nitrogen-free extractives. The moisture content is determined as the loss in weight that results from drawing a known weight of food to content weight at 100 grades. This method is satisfactory for most foods, but with a few, such as silage, significant losses of volatile material may take place. Therefore, for silages, the moisture content can be determined directly by distilling the water from the sample under diluting. The distillate is measured and corrected for the presence of fermentation acids and alcohols. The ash content is determined by ignition of a known weight of the food at 550 grades until all carbon has been removed. The residue is the ash and is taken to represent the inorganic constituent of the food. The major component of ash is silica, but ash may, however, contain material of organic origin such as sulfur and phosphorus from proteins and some loss of volatile material in the form of sodium, chloride, potassium, phosphorus, and sulfur will take place during the ignition. The ash content is thus not truly representative of the inorganic material in the food, either qualitatively or quantitatively. Animals do not have a requirement for ash per se, but require the individual mineral elements that it contains and are determined by methods such as atomic absorption spectrometry. The crude protein content is calculated from the nitrogen content of the food, determined by a modification of technique originally devised by Kjeldahl over 100 years ago. In this method, the food is digested with sulfuric acid, which converts to ammonia or nitrogen, present except that in the form of nitrate and nitrite. This ammonia is liberated by adding sodium hydroxide to the digest, distilled off, and collected in standard acid. The quantity so collected being determined by titration or by an automated calorimetric method. It is assumed that the nitrogen is derived from protein containing 16% nitrogen, and by multiplying the nitrogen figure by 6.25, i.e. 100 in 16, an approximate protein value is obtained. This is not true protein, since the method determines nitrogen from sources other than protein, such as free amino acids, amines, and nucleic acids, and the fraction is therefore designed crude protein.